Every time a barcode passes a scanner, a modern point-of-sale system generates an instant data point. As we saw when looking at how information systems operate, businesses today capture an immense amount of daily transactional data. Without a structural framework to hold it, these thousands of daily transactions remain a chaotic, unsearchable pile of digital records. A database management system, or DBMS, is the software framework that managers use to capture that chaos, organize it, and translate raw data into actionable business strategy. For a retail startup, a relational database organizes inventory and customers into specific tables. Notice the connecting lines. A primary key uniquely identifies a single shopper, while a foreign key links that shopper to their purchases in the order table. Because these tables are locked together, the system enforces what is known as referential integrity. If a manager tries to delete a customer profile that still has an active pending coat order, the system blocks the action to prevent creating an orphaned record. By enforcing rigid, logical links between isolated pieces of data, relational databases protect the overall accuracy of a company's information. Once the data is securely structured, managers need a way to extract strategic value from it. They do this using SQL, or Structured Query Language, which is the standard programming language used to ask a database targeted questions. For example, a manager can write a query asking the system to reveal which regional zip codes purchase the most winter coats. The database reads the code and maps out the high-volume sales areas. Through SQL, a static storage system becomes an active strategic tool for operational decision-making. Fast forward 5 years, that small startup is now a global enterprise. Instead of just tracking checkout receipts, they are monitoring millions of social media mentions and web interactions every single day. This visual represents big data, which is characterized by its volume, variety, veracity, and velocity. When a high-speed influx of diverse, unstructured files hits a traditional relational database, the strict grid structure breaks under the pressure. To survive at a global scale, a company must abandon rigid data frameworks for systems built to handle chaotic, varied information streams. Enterprises manage this by shifting to cloud databases and NoSQL systems. NoSQL dissolves the rigid tables in favor of a flexible, document-based structure that easily absorbs mixed streams of photos, text, and video. A marketing team can use a NoSQL database to instantly aggregate unstructured Instagram tags and customer support chat logs to measure public sentiment about their brand. By trading the strict formatting rules of relational tables for structural flexibility, NoSQL makes it possible to track and understand complex global consumer behavior. Keeping these massive enterprise systems secure and optimized requires a highly specialized IT role, the database administrator. A critical part of their job is overseeing data scrubbing. This is the continuous process of auditing massive datasets to find and remove formatting errors, duplicates, and typos. If a single typo records 30,000 coats in inventory instead of 3,000, that unscrubbed error triggers an automated chain reaction that can entirely drain a procurement budget. At an enterprise scale, the predictive power of a database is entirely dependent on the audited accuracy of its underlying data. As companies scale, they often end up with perfectly structured SQL data isolated in one department and messy NoSQL data locked in another. Organizations solve this fragmentation using business intelligence tools and data warehouses. A data warehouse is a centralized repository combining all of a company's data into one place. By breaking down departmental walls, data warehouses give executives a singular, holistic view of the company's past and present operations. This animation shows an OLAP, or Online Analytical Processing, data cube. To perform advanced multidimensional analysis, managers use this tool to stack and align different variables, like historical sales data, directly against real-time weather patterns. A supply chain department can combine historical coat sales with a coming blizzard's weather analytics to forecast shipping bottlenecks before the snow even starts falling. Business intelligence systems can elevate a manager's role from reacting to historical data to accurately forecasting future disruptions. The cutting edge of management information systems now integrates artificial intelligence. AI can autonomously scrub data, translate a manager's natural language into complex SQL queries, and spot hidden patterns inside millions of rows of data. The modern database functions as the strategic brain of a company. For a manager, the ability to leverage that data is a defining competitive advantage. The next time you interact with your favorite digital platform, ask yourself, how are these structuring their database to predict exactly what you will want next?